Hello, everybody. Welcome back. Today we're going to be looking at Unit 7.6, which is all about some of the properties of the equilibrium constant. So let's get started. So I want you guys to think back to our last unit, Unit 6, and the very last subunit in Unit 6, which was all about something called Hess's Law. And if you remember, what Hess's Law problems involved is you were given a series of what are called elementary step reactions. And your job was to rearrange those equations so that when they added together, they equaled the reaction that we were given. Like usually a Hess's Law problem would give you some overall reaction and say, what is the change in enthalpy for this reaction? And then you were given a bunch of elementary steps to manipulate so that when they added together, it equals the overall reaction. And if you'll recall some of the things that we did to manipulate those equations, sometimes we flipped them around, sometimes we had to multiply by a coefficient. We're going to be looking at those kinds of problems again, but this time, instead of tallying up an enthalpy value, we're going to be calculating an equilibrium constant for that overall reaction. So just as an example, I want you to look at these two reactions. Look from the first reaction and move your eyes to the second one. What happened? Can you see that all we've done is flip the reaction around? We've flip-flopped reactants and products. So let's imagine that the first reaction has an equilibrium constant value equal to 10. Remember, guys, the equilibrium constant is just molarity of the products over molarity of the reactants. If you flip-flop those positions, you're not going to make the K value negative. There's no such thing as a negative K value. You're going to flip-flop numerator and denominator. So the K value for this reaction, when we flip it around, is actually the reciprocal of that first K value. Okay, so if you flip a reaction around and you need to come up with what is that new K value, you take the reciprocal. Okay. Again, what are some of the other what's another way that we manipulated these elementary steps in a Hess's Law problem? We also sometimes not just flipped them around, but sometimes we also multiplied the coefficients in a reaction by some number. Okay. So this time, move your eyes from the first reaction to the second. What happened? Notice that we have multiplied all of the coefficients times the number 2. Okay, well, remember, where do coefficients end up in an equilibrium expression? They become the exponents. So if I've multiplied this reaction by times 2, I'm not going to multiply the equilibrium constant times 2. I'm going to raise it to the power of the number that I multiplied by. So I went from the top equation to the bottom, I multiplied by 2. So I'm going to raise my original K value to the power of 2. Okay. So let's look at an example. All right. Let's say we have these two reactions, okay? And let's imagine that I have already manipulated these two elementary steps, and they are the way that I want them to be. Remember, when you add equations together, you can cancel out any substance that is identical on the left and the right of the arrow, okay? So, for example, let me change color here. This and this. Two of those nitrogen monoxides, those get canceled out because they're on opposite sides of the arrow. And then I bring everything else down. One nitrogen, two oxygens, two nitrogen dioxides. Now guys, look what happens to the K value, okay? Unlike when we were dealing with enthalpies, when we had enthalpies in this position and this position, we just added the enthalpies together to get our total. We don't do that with equilibrium constants. We multiply them together to get a final answer. Okay, so once you have manipulated your elementary steps the way you want them to look, and you add your elementary steps together to get the overall equation, okay, you will multiply each individual step's K value, multiply them all together to get the final equilibrium constant for that overall reaction. All right, so what I want you guys to do is pause your video and try this problem. All right, let's see how you did. Let's talk through, let's review the thought process in these Hess's Law problems, okay, like we've done before. So this is my overall reaction that I want my elementary steps to add up to equal. So my way of doing these problems is I start with the first reactant, N2 gas. Here it is. Does it have the correct coefficient? Yes. But is it on the correct side? No. So what I'm going to do is I'm going to flip that reaction around and I'm going to rewrite it just below. Okay, and when I reverse a reaction, that K value isn't K2 anymore, it's 1 over K2. And I'm going to scribble through this guy because we don't need him anymore. Okay, so I've taken care of this. My oxygen looks good. Let's deal with this bromine next. Okay, I see bromine right there. Is it on the correct side? Yes. Okay, but does it have the correct coefficient? No, it doesn't. I'm going to need to multiply this top equation times 2. So I'm going to rewrite it. 2NO gas plus Br2 gas 2NOBr, and what happens to my K1? It's not K1 anymore. Since I multiplied by 2, it's now squared. And I'm going to scribble through this equation since I don't need it anymore. Okay, and let's just make sure that when I add these two equations together, I end up with what I'm supposed to. I can see that's going to cancel with that, and that leaves me with the equation I was supposed to. Cool. So I know I manipulated my equations correctly. The last part, what they're actually asking us is, what is the K value for this equation, the overall? And remember, what do we do with these individuals? We're going to multiply them together. And if you look at your answer choices, letter D matches that description. Okay, so we've talked about, you know, what the magnitude of the equilibrium constant means in the last unit. And now we have talked about, you know, some of the things that you can do with that equilibrium constant value. Okay, so we're going to get into some of the more heavy-duty calculations coming up in the next couple of subunits, so get ready. But I hope you have learned a little something today, and I look forward to seeing you next time.